Quaoar is a dwarf planet located in the Kuiper Belt, a region of icy bodies beyond Neptune. It was discovered on June 4, 2002, by American astronomers Chad Trujillo and Michael Brown at the Palomar Observatory. With a mean diameter of approximately 1,097.6 kilometers, about half the size of Pluto, Quaoar ranks among the largest known trans-Neptunian objects. Quaoar has a slightly ellipsoidal shape and a moderately reddish surface composed of crystalline water ice, ammonia hydrate, and traces of methane. It orbits the Sun at an average distance of 43.7 astronomical units AU, completing one revolution every 288.8 Earth years. Its orbit is nearly circular and stable over long periods. One of Quaoar's most surprising features is its ring system, discovered in 2023. These rings lie well beyond the Roche limit, a region where rings were previously thought to be unstable, challenging current theories of ring formation. Quaoar also has a confirmed moon, Quaoar, named after the Sky Father in Tongva mythology. The name Quaoar comes from the Tongva people, Native Americans indigenous to the Los Angeles area. In their creation myth, Quaoar, is the genderless cosmic force that sings and dances the universe into existence. Size comparison. Quaoar has a diameter of approximately 1,110 kilometers, about 690 miles, making it half the size of Pluto diameter 2,377 km, slightly smaller than Saturn's moon Dione diameter 1,123 km, roughly one-third the diameter of Earth's moon, diameter 3,475 km, comparable in size to the U.S. state of Arizona or nearly twice the size of the United Kingdom among dwarf planets. Quaoar is smaller than Pluto, Eris, Haumea, and Makemake, but larger than Ceres 940 km. It ranks as one of the largest classical Kuiper Belt objects. Its moon, Quaoar, is about 160-170 km in diameter, similar in size to Saturn's moon Mimas. Time. Quaoar completes one rotation every 8.84 hours, making its day less than a third of an Earth day. Some sources cite a synodic rotation period of 17.68 hours, which may reflect variations in measurement or observational methods. Orbit. Orbital period. Approximately 286 Earth years, 104,450 days, though estimates range from 284.5 to 288.8 years. Semi-major axis. About 43.7 astronomical units AU from the Sun eccentricity, low at 0.041, indicating a nearly circular orbit. Perihelion, closest to Sun, 41.7 AU aphelion, farthest from Sun, 45.5 AU inclination, 8 degrees relative to the ecliptic plane, typical for classical Kuiper Belt objects. Quaoar's orbit is stable and resides in the classical, cold, Kuiper Belt, distinguishing it from more dynamically excited trans-Neptunian objects. Discovery. Quaoar was discovered on June 4, 2002, by American astronomers Chad Trujillo and Michael Brown at the Palomar Observatory in California. The discovery was made using the Samuel Oschin telescope as part of the Quaoar Wide Area Sky Survey, which aimed to identify bright Kuiper Belt objects. The object was first noticed in images taken on June 5, 2002, moving through the constellation Ophiuchus. The discovery team later found precovery images dating back to May 25, 1954, extending Quaoar's observational arc. The announcement was officially made on October 7, 2002, at an American Astronomical Society meeting. Quaoar was initially designated 2002 LM60 before receiving its permanent minor planet number, 50,000. Quaoar. Planetary structure. Quaoar has a differentiated internal structure, consisting of a rocky core surrounded by a thick icy mantle. With a density of approximately 1.75 GeM, it suggests that the dwarf planet has undergone interior compaction and layering. Core, likely composed of silicate rock, formed through early radiogenic heating. Mantle, primarily made of crystalline water ice, with traces of ammonia hydrate and methane, indicating past internal heating or cryovolcanic activity. Surface, features crystalline ice, which requires temperatures above 110 K to form, suggesting resurfacing via impacts or cryovolcanism. Despite its cold surface 50 K, the presence of crystalline ice implies geological activity in the recent past, as cosmic radiation would otherwise turn ice into an amorphous state over millions of years. Weeward, formal designation, 50,000. Quaoar I, is the only confirmed moon of the dwarf planet Quaoar. It was discovered on February 14, 2006, by Michael E. Brown and Terry Ansua using images from the Hubble Space Telescope. Name: Weeward is named after the sky god and son of Quaoar in Tongva mythology, honoring the indigenous people of the Los Angeles area. Size: estimated diameter of 170-200 km, making it one of the larger known moons among trans-Neptunian objects. Orbit: average distance, 13,300 to 14,500 kilometers from Quaoar orbital period. 12.4 days. Eccentricity, 0.018 to 0.15. Nearly circular inclination, 14 to 15 degrees relative to the ecliptic. Weeward orbits outside both of Quaoar's rings and may play a role in maintaining the outer ring via orbital resonance. Physical characteristics: albedo, 0.04, making it one of the darkest known satellites in the trans-Neptunian region. Likely composed of dark, organic rich material typical of Kuiper belt objects. Weeward is believed to have formed from a giant impact or from a debris disk, and its orbit suggests long-term stability. Recent observations hint at a possible second satellite or ring arc near its orbit, but this remains unconfirmed. Early history formation. Quaoar formed over 4.5 billion years ago in the Kuiper belt, a relic region of icy bodies beyond Neptune. It is considered a primitive remnant from the early solar system, originating from the protoplanetary disk of gas and dust that surrounded the young sun as a classical Kuiper belt object. Quaoar likely formed in situ or near its current orbit, avoiding major gravitational disturbances from Neptune. Its nearly circular orbit and low inclination suggest it belongs to the cold population of the Kuiper belt, objects that have remained dynamically stable since formation. Quaoar's composition, rocky core with a thick icy mantle, indicates it underwent partial differentiation, driven by heat from radioactive decay in its early history. The presence of crystalline water ice on its surface suggests past internal heating or resurfacing events, possibly from impacts or cryovolcanism, which prevented the ice from becoming amorphous under constant cosmic radiation. As one of the largest known trans-Neptunian objects at the time of its discovery, Quaoar provided key evidence that Pluto is not unique but part of a broader population of icy dwarf planets, reshaping our understanding of the solar system's outer reaches.